In section 7.1, we're going to start to talk about this process of hypothesis testing, which is really going to be kind of the large culminating focus of our semester. And it's going to really revolve around a lot of the ideas that we've already been talking about. Namely, how do I use the ideas of probability to help me make decisions in complicated sorts of scenarios where a question and its answer may be unknown. So we're going to try to get a sense of what sorts of questions we're going to be asking and how we're going to make use of some of the things that we had just previously ended talking about in Chapter 6. Let's go ahead and jump in here by taking a look at our first example. Just prior to the presidential election, in a random sample of 800 voters, 424 preferred candidate X over candidate Y. A news organization claims that this means that over half of Americans will vote for candidate X. First off, notice here that the news organization doesn't know this, they're just claiming it. It's kind of like a belief that they hold. So because over half of the people have voted for this person in the sample, the news organization believes over half of everybody is going to vote for this candidate. Well, can the news organization reasonably make this claim? I mean, are they making a good educated guess here, or is it not maybe the best educated guess? Let's take a look here at all the different parts of this question. There will be a lot of them. We'll try to see how exactly we can start to answer this question. So one of the first things that we have to understand is that there is a population parameter that the news organization is claiming to know something about. And so this is where part A comes in. What is that population parameter that the news organization is claiming to know? And so I'll go ahead and write here that the news organization is claiming to know the value of P. Okay, and by P, remember that we talked about this in the last section, where P stood for the population percentage. Or in this case, the specific population percentage is the percentage of all voters who will vote for candidate X. So this is what the news organization is claiming. They're saying, I think I know something about the value of P. Specifically, they're claiming that over half of Americans will vote for this candidate. So they're claiming that whatever this mystery P percentage is, they're claiming it's bigger than half, bigger than 50%. Okay. Now, of course, the news organization, is doing at least a decent job of not just making this number up out of thin air. They're trying to base it off of something. So we could say here in part B, what is the sample statistic that this news organization is using to help make their claim? Well, that's also pretty easy to see because we can see that there were 424 voters out of 800 total that said they were going to vote for candidate X. So our sample statistic here is, let's see, the sample statistic is P hat, which is the percentage of the 800 voters who said they would vote for candidate X. Okay. Now again, up here I should note that I don't really actually know what this value of P is, right? Like up here, this value of P is a mystery. However, when we talk about the value of P the value of P hat that's listed down here, we can actually compute this value, right? Because we actually know how many individuals there were that were surveyed, and we know the number of individuals who actually said they would vote for this person. Now you could actually go to a calculator and crunch this value out, and I think you end up with that it's 53%. So the news organization is seeing that 53% of these 800 individuals are going to vote for the candidate, so they're making a claim as to what everyone's going to do. Well, The news organization is really doing something that we kind of did back at the beginning of this semester, where we talked about the idea of using simulations. And in those simulations, we often had two hypotheses. Well, let's take a look at what those two hypotheses would be here. Remember that my two hypotheses are meant to try to explain why it is we're seeing 53% of people voting for candidate X. And so here's at least one possible hypothesis. Oops, let me go ahead and reword that like this. So I'll say I have hypothesis 1, and I'm going to go ahead and remember that hypothesis 1 was often like a boring kind of hypothesis. It said, you know, nothing really interesting is going on here. Maybe like no candidate is really like, you know, going to be winning at this point in time. Maybe it's kind of just like a 50-50 split. So maybe I could say something like no candidate is the favorite at the moment. That is, nobody is winning all or majority of the votes. So I could say they both have 50% of votes. And maybe I could just say here that this was a lucky sample, right? Like it just happened to, just by chance, show that this person was getting 53%, right? We just happened to find a couple more people that were going to vote for candidate X. So if I'm kind of putting this hypothesis here into some symbols, I could think about this as saying that the value of P that's up here, right now, this hypothesis would claim that this value of P is really just 50%. Okay? Now again, this is just a guess. It's just a hypothesis. It's one thing that could explain why P hat came out the way it did. The real value of P is just 50%. Candidate X is only getting half the votes. This was just a sample where we happen to have a couple more candidate X fans. Okay, well, if that's one possibility, then we should be able to list out another possibility. Hypothesis number 2. In hypothesis number 2, we could say that the reason that we're getting 53% here in our sample is because candidate X is the favorite. That is, this candidate is going to win actually over 50% of the vote, and we can see that in the fact that they're winning over 50% of the vote here. So I'll go ahead and just say this candidate is the favorite and will win a majority of the votes. So notice in this case, I'm kind of stating that the value of P is, well, still kind of unknown, but at least that it's bigger than the value of 50%. So this is kind of the general idea. We're going to take these two hypotheses and we're going to try to figure out which one of them we would think is the safer bet. Now remember, from when we talked about testing hypotheses back with our simulations, it was very important for us to be able to always test this first hypothesis that indicated that the sample was lucky. What we're doing in our tests is we're going to try on what it feels like to say that the probability or the chances that or the percentage of the votes that this person is going to get is half. And we're going to see how well that fits in terms of some probability scenarios. And we'll talk about that in the next video.